All right, here we go. Lesson 11.2, areas. We're dealing with units squared in this problem, in this whole chapter, in fact. We begin by looking at areas of triangles. Before we go to the nitty-gritty, remind yourself that you need to deal with units squared. So there always needs to be a word after your answer with a power of 2. If it's not there, just write the word units. Or you can say like so many u squared. Yeah? And again, what we're literally thinking is, okay, this shape I have looks like a sideways ice cream cone. What is the area of it? And how many squares would fit inside that? Which again makes it a little tricky for triangles, because a triangle, again, if I think about the squares that inside here, they have this oblique edge, kind of a slanted edge. So it's hard to envision that. Well, there's a formula, and hopefully you know it by now, but 1/2 base times height is how we get the area. Now keep in mind these dimensions have to be perpendicular, so never grab dimensions of base and height that do not meet at 90 degrees. All right? Second of all, it's a little bit tricky because sometimes they'll give you something like this, and the question is, what base do I use? Because you could use a base here. Whoop, sorry about that. Could use a base on this side, or you could use a base on any side. Yeah? But whatever base you pick, then you automatically are looking for the height. And again, that height would need to be perpendicular. Watch out when the triangle looks like this, because here it's a little bit hard. Again, you can pick any of the 3 sides. If it's oriented like this and you like your base to be on the bottom, that's fine. Here is your base. But you need to extend that base out to just below the highest point, because that's where you're going to calculate the height. All right, so there's the height and the base on that particular problem. All right. Next unit, you're going to deal with trapezoids, but could I break a trapezoid up into rectangles and triangles? And the first job most kids do is they go, yeah, I see the 2 triangles, and there's the one, and then there's the rectangle in the middle, right? Okay, is there another way? And some kids say, yeah, you do that. Other kids say, take this triangle and put it over here. And then you end up with a kind of a rectangle like this. And provided it's isosceles, you can do that. The one final way that I'd like you to think about this, though, is you could draw a line down the middle that is parallel to the 2 bases. And that parallel side, you can now think of it as helping you build a rectangle, because I could take this triangle here, yeah, provided it's a right triangle, and this triangle here, and I could flip those 2 triangles down here, and therefore end up with a rectangle that looks like this. Okay? That would be equivalent to the area of the trapezoid. And this is an important way to begin thinking about trapezoids and how to find the areas of them. In fact, any particular shape. All right. Before we leave you to the problems, keep in mind we have an area of what we would call a trapezoid. Sorry, parallelogram. Parallelogram. Didn't spell that right at all. All right. Notice it has, again, a couple triangles. You could cut it off there and find those areas. But the shortcut is just take the base times the height. These 2 bases that we have here are not actually 2 different bases, but they're the same base. So whatever base that is times whatever the height is, and that gives you the area. Okay? It's going to be tricky to find. You know, sometimes they're going to give you, say, a number over here, and they're going to say, what is that distance? And then you're going to be clever because you're going to create a little right triangle here, and then you're going to find this height. All right. And that's it. Have a great time on those homework problems right there, 3 to 11, 17, 19, 26, odd.